You're listening to Inside iOS Dev, show about real-world iOS development. Today with you, your host, Alex Bush. And today's topic, unit testing 101. Well, first, let's start with definitions. What is unit testing? Unit testing is a software development technique that, in a sense, means that you're writing a different application that tests parts or units of your production code, your application. And what it means specifically, there are various types of testing techniques, and unit testing is one of them. And you can sort of, if you look at all the types of tests that you could possibly be doing, you could arrange them in so-called testing pyramid. And at the top of the pyramid would be the most complex and expensive tests to write and to run and execute, like UI and integration tests. And at the bottom of the pyramid, tests that are easier and faster to write, types of tests called unit tests. And the UI tests at the top of the pyramid, they test sort of a broader swaths and parts of your app or the entire application, and unit tests only focus on particular parts. So today we'll be talking about unit tests specifically. So the reason they're called unit tests, there are lots of sort of history in the background around the whole unit testing topic, but essentially unit tests test units of your code. And typically what unit is a small portion of your code base, such as a class or a method. And a commonly asked question is, what should be tested in your classes? Essentially, a short answer, you would want to test only publicly accessible methods of your class, essentially public API. You rarely would test public properties because they typically do not have any side effects or don't trigger any changes in your system and your class that you're testing, but they might. So essentially anything that might have side effects or return direct value and is publicly accessible is what you would be testing in your class. So all the public or internal methods, but you would not test private methods or private variables, because that's internal implementation of your class and it should not be tested. That's something that will change, and if you do that, you essentially make your sort of implementation of your class very hard-coded, if you will, very, very strict and hard to change. And that's not what the rest of your code should be relying on, right? Because when other parts of your application and other classes use that class that you're trying to test, what they're really going to be coupling themselves to and relying on would be public APIs of that class, what's publicly accessible, not its internal details. After you identified what to test, you would need to validate results of the methods you're calling. For that, you would use assertion methods, and Apple provides us with a set of assertion methods, assertion functions with XC test framework that's built into iOS. It's, for example, it will have methods like XC assert equal to check equality of two objects that you've got or two primitives, or XC assert true to check if the value that you're checking is true. Or XC assert false to check if it's false, or XC assert nil, non-nil to check if it's nil or non-null, things like that. Those are the main ways for you to validate the output of your test, and they're actually built into Xcode, and Xcode will show you if one of those assertions fails. It will have a little indicator showing a red sign, a red X. In a circle, which means that the assertion failed, which means the test has failed, or it will have a green check mark if assertion passes. That means the test passed. And you can have multiple assertions per test. Although it's not recommended, a typical sort of a best practice is to have only 1 or 2 assertions per one unit test method, because the idea is that if you are certain on too many things, that means you're testing and trying to validate too many things at a time, and likely they should be broken down into multiple test methods. XC test framework is also, it provides you with a structure to organize your testing code. And the way it works, you implement, you subclass from XC test case class and implement your own class that has a collection of testing methods. Every method that starts with a prefix test and then anything else, could be any name of the method, but it needs to start with test, will be picked up by the system and executed and launched when you click run tests in your Xcode, or when you run XC test or unit test command from terminal. Essentially, this word test indicates that this is a test method. It will be executed, and any assertions methods in it will be triggered. And if, as I mentioned before, if they pass, then it's going to be green. If they don't pass, it's going to be red and tell you where the error and the problem was. Any private methods or any other methods in that testing class that do not have test prefix in it will be ignored, or rather, they won't be launched as a part of the unit testing suite, and instead they either just sit there unused, or maybe your unit tests actually use those methods as helpers to run the tests. This structure typically that means that you will have at least one unit test class or test case class per class that you're testing, but you might have more, depending on maybe for different scenarios or different contexts of your class that you're testing. You want to organize code and sort of prerequisites and the environment and params differently, and in that scenario you might want to have multiple of them. And then you'll have of course in each one of them several methods for testing, several testing methods for testing publicly available API of your class, right? Those public and internal methods. And also per each method you will have, well, you should have at least one test method, test function, but also quite often you'll have multiple actually for different use cases. So let's say you're, I don't know, you have a calculator of sorts and it has a method calculate, and if you give it 2 params, it's supposed to return, it's supposed to add them together and return the result of that. So you'll have at least one method where you give it, I don't know, 2 and 2 and it returns 4, and then another, but you might want to have another test case, another test function where it gives it different types of params, such as 2 and 3, and the result, you validate that the result either is 3 or it's the result is not 4, to sort of a double check that it works with several scenarios and several cases, not just that one. And this brings me to another topic: how to structure your test functions, your test methods. The best practice for structuring them, you can, roughly speaking, it can be free form, and you can organize them however you want it. Just in a nutshell, it's a normal method, a typical method that is just called by the system at the time when your unit test suite is executed, right? So any normal code there, any computations, any initializations or whatnot that you could do there. But the best practice is to organize your testing methods into a group of 3, a set of 3 things, 3 groups of code. It's called given, when, then. So in the given part of your test, you're sort of arranging and organizing your code, and you're setting up your system under test. And the system under test is the class, the object that you're trying to test, right? The object on which you will be calling a method, the result of which you would like to unit test, right? So in the given part, this is the first portion of your test function, test method, is where you would organize and arrange everything. First of all, you would initialize and create that system under test, that object that you're trying to test. And then in order to create it, if it has any dependencies, you would create any dependencies, objects for dependencies that you need to inject in it. And also you might create in the given part, you might create other objects or params or whatever you need to pass into the method that you will be testing. Then in the second part of the test method, it's called when. When is sort of what happens, the action, right? When the method you're testing is called. And this is where literally it's typically just one line. This is, you'll take your object that you're testing and call the method that you're testing on it. And then either if it has a result return value, you capture that return value in a result variable, or you can call it whatever you want, but result is a typical name. And or you don't capture, right? If it doesn't have any, it doesn't return anything, just has side effects. And then the last part is then. This is the assertion portion. That's where you would put all of your assert calls, assert methods. Usually, again, as I mentioned before, it's typically just one assertion per test method, but you might have more if you're validating multiple outputs, or the output is complex, or if there are multiple side effects to calling that method that you're called in the when section. Quite often a very complicated case and sort of a deterrent and something that people stumble upon as they start unit testing is how to test side effects, right? As I mentioned in the previous section, what if you have a return value, you just capture it in a variable, and it's pretty straightforward. You call assert methods, XC assert methods on that return value, and then you check if it's correct or not. What do you do if your method that you're testing doesn't return anything, right? And that's a lot of methods, usually in iOS applications. They do some action, but it's a side effect, right? It's not a direct return computed value. So in this case, this is a slightly more advanced technique, and I'll have a standalone episode about it. It's mocking and stubbing, but what you would use as mock object that you inject in your system under test, and in that object that you're testing, that will record any side effects that you expect to happen, right? So let's say you have I don't know, to overly simplify, you have a view controller, right? And you, after view did load is called, you want to test, because view did load doesn't return anything, right? It has no return value, but you want to test that view, upon view did load, the view controller called a networking client, requested data from the network, right? But what that really means, it means that networking client that it has inside, right, that was injected in it, had a method get data or fetch data called on it at least once, right? And that's where you would create, instead of having an actual client object in this code, when you're running your unit tests, you would create a mock object that doesn't really actually call the network, but behaves like a client, a networking client that does. But instead of calling the network, it actually just records the fact that the method to get the data was called. right? Maybe it could even record params and things like that. And then in your assertion part of your then part of your test, right? Given when then, you would assert that in this mock object, the counter of calling the method to fetch the data was greater than 0 or was specifically 1. But again, this is a topic for another episode. It's going to be unit testing 102 episode, and I'll cover that more in details on how to mock and stub objects in your unit tests, and how to test and validate side effects of method calls. All right, guys, that's it for today. That was Unit Testing 101, Introduction to Unit Testing on iOS. You can reach me at hello@insideiosdev.com or on Twitter at insideiosdev. And I'll see you next time.